folks, welcome to another set of 8th grade science video notes. Today we're going to learn about the law of conservation of mass and how to balance chemical equations. To start off, let's talk about the law of conservation of mass. The law of conservation of mass states that in any ordinary physical or chemical change, mass cannot be created nor destroyed. In other words, the mass you have before a chemical or physical change occurs will be exactly the same as the mass you have after a physical or chemical change occurs. There are a number of chemical and physical reactions that we could do in class to show that the law of conservation of mass is true. Let's look at a couple of examples. First off, if you cut a piece of wood in two, that is a physical change. We still have a piece of wood when we're done. If you take the mass of the wood before you cut it and the mass of the two pieces of wood after you cut it, plus any sawdust that you got while you were cutting it, the masses will be exactly the same before and after. That's because we didn't lose any of the wood or gain any wood. Chemical changes can be a little bit trickier to see this in, especially if there's a gas or there's bubbles that are produced, because it's hard to trap the gas. However, if you take two liquids, mix them together, and it forms a precipitate within the liquid solution, if you measure the two liquids separately beforehand, and then measure the liquid and solid mixture afterwards, the mass should be exactly the same. Chemical changes are also known as chemical reactions. They're nothing more than a rearrangement of atoms. Those are 10 words that you need to know by heart. So say them with me. Chemical changes are nothing more than a rearrangement of atoms. Yeah, see, now you're getting it. I know you learned that chemical changes happen when we produce something new, but the truth is we never actually get anything new. We might get a different substance, but it's all made out of the same atoms. They're just bonded in different ways. So the atoms within the molecules that we have will break their bonds and they'll split apart and they'll mix up and they'll bond together with other atoms in a different combination, which does change one thing into another, but it's all the same atom. For example, when we light hydrogen gas, which is H2, on fire, it reacts with oxygen gas, which is O2. For this reaction, it takes two molecules of H2 and one molecule of O2. They break their bonds, they rearrange, and they end up making two molecules of H2O. Yeah, water is new, technically, in this case. Something different than we had before. But if you look at the atomic level, we have exactly the same number of atoms before and after the change. If we counted them up, you'd see we started with 4 atoms of hydrogen and 2 atoms of oxygen. And after the change, we still had 4 atoms of hydrogen and 2 atoms of oxygen. They're just bonded in a different way. So this right here is exactly what the law of conservation of mass is talking about. Whatever we start with in a chemical change, we end up with in a chemical change, and they have to be equal to each other on the atomic level. So you know that chemical symbols represent the names of elements, such as H is hydrogen, Li is lithium, F is fluorine. And you know that chemical formulas represent molecules, and they help us understand how many atoms of each element are in the molecule. But then we have chemical equations, which is just one step further, and those represent chemical changes or chemical reactions. So let's look at the chemical equation we just used. We see that we have chemical formulas such as H2, O2, and H2O. In case you forgot, those little numbers down at the bottom, those are called subscripts, and they tell us how many atoms of each of those elements are within the molecule. So for H2, there are 2 atoms of hydrogen, or for H2O, there's 2 atoms of hydrogen and 1 atom of oxygen. The only other numbers we have in a chemical equation are the big numbers in front of a chemical formula. These are called coefficients, and they tell us how many molecules of that substance we have. So in this case, we have 2 molecules of H2, 1 molecule of O2, and 2 molecules of H2O. Lastly, we've got the big arrow in the middle. This splits up the before and after sections of our chemical change. Before the arrow, we have the reactants. We call them reactants because that's what we're reacting together. That's what's going to go through the reaction. Afterwards, we have the products, and those are the substances that are produced. So, reactants on the left, products on the right. So let's look at an example of a balanced chemical equation. Here we have barium chloride and copper sulfate, and that goes through a reaction to give us barium sulfate and copper chloride. If we go through and count up all of the atoms, we should notice that we have the same amount of atoms of each element on either side of the equation. So for barium, on the reactant side, we have one atom of sulfur, 4 atoms of oxygen, 1 atom of copper, and 2 atoms of chlorine. And then on the product side, count them up again, we have exactly the same numbers. So on either side of the arrow, the reactants and the products, we started with a certain amount of atoms, and we ended up with the same amount of atoms, they're just rearranged differently. Again, this is the law of conservation of mass. Anytime we have a chemical equation, it has to be balanced because the law of conservation of mass says it does. If it weren't balanced, it wouldn't be real. It would be saying that we've lost or gained atoms somewhere in the process, and that just doesn't happen. So here are 6 simple steps that you can use to balance an equation, and then we'll go through some examples. Step 1, write down the symbols of each element that you have right underneath the arrow. Step 2, count up how many atoms of each of those elements you have on the reactant side. Step 3, count up how many atoms of each element you have on the product side. I personally like to write them to the left and the right of the symbols that you just wrote down. You could also just do 2 columns of symbols, one for the reactants, one for the products. The 4th step's really easy. You compare those numbers. Are they the same on both sides? If they're the same, then you're done. You've balanced your equation. If they're not the same, you need to add molecules of whatever substance has the element that you need more of. Coefficients are like subscripts in the fact that we don't write ones. So when you have blank CuCl2 in your equation, and you need to add another molecule, you already have 1, add 1 more, you have 2. So the first number you put in as a coefficient is 2. Once you have changed a coefficient, you stop right there, recount your atoms. Make sure that you know exactly how many atoms you have on the reactants and product side after you've changed the coefficient. The next step is to go back to step 4. Are those numbers the same? Do you have the same amount of atoms? If you do, great, you're done. If not, keep changing coefficients until you get it right. So let's go over to the board and run through a few of these examples. Okay, our first equation says Li plus Cl2 gives us LiCl. So, what's the first step? Write down the elements that you have. We have Li, we have Cl. Second step, count up how many reactants you have. You've got 1 atom of Li and 2 atoms of Cl. And on the product side, we have 1 atom of Li and 2 atoms of Cl. So now you stop and evaluate. We've got 1 and 1, that's good. Then we have 2 and 1. That's not right. We need another Cl over here. We cannot change the little subscripts down here because that would change the substance we have. So we have to change the coefficient. Instead of 1, which is already there, we'll put a 2. Then we stop and recount. That now gives us 2 Li's on the right and 2 Cl's. So go back to step 4, evaluate it. We've got 2 and 2 for Cl, that's great now. But for Li, it's just 1 and 2. So we go back to this side, add another coefficient, add another atom of Li, and now you have 2 Li's. Evaluate it again, 2 and 2, 2 and 2, you're balanced, you're all done. Our next problem says that we have zinc plus hydrochloric acid gives us zinc chloride plus hydrogen gas. So, what's the first step? Write down the elements you have. We have zinc, we have hydrogen, we have chlorine. Second step, count up the atoms we have on this side. We've got 1, 1, and 1. On the product side, we have 1 zinc, 2 chlorines, and 2 hydrogens. Okay. Stop and evaluate. You've got 1 and 1 zinc, that's great, but you have 1 and 2 hydrogen. So you need to get more hydrogens on the reactant side. To do that, we would change the coefficient here from 1 to 2. Stop and recount. Our zinc doesn't change, but that changes our hydrogen to 2 and our chlorine to 2. Now evaluate it again. We've got 1 and 1, 2 and 2, 2 and 2. That's it. That's all you've got to do. And lastly, we have sodium plus water gives us sodium hydroxide and hydrogen gas. Write down the elements you have. We have Na, we have H, we have O. Count them up. 1 Na, 2 H's, 1 O, 1 Na, 1 O, and we have 1 H here, plus these 2 gives us 3. So, we've got 1 and 1 for sodium, 1 and 1 for oxygen, but 2 and 3 for hydrogen. So we need more hydrogens on this side, right? The only way to do that is to change how many molecules of H2O we have. So instead of 1, we'll put 2. And we got to stop and recount. That changes our H's to 2 times 2 is 4, and 2 times 1 oxygen is 2 oxygens. Evaluate it again. We have 1 and 1 Na, 4 and 3 hydrogens. So to get 1 more hydrogen on this side, we wouldn't change that one. That would give us 2 more. So if we want 1 more over here, we put a 2. That gives us 2 Nas. 1, 2 hydrogens plus those 2 is 4. And 2 times the 1 oxygen is 2. Last step, evaluate it again. We've got 2 and 2, 4 and 4, but 1 and 2. That's not quite right. We're almost there. We have Na all by itself here, so instead of 1 atom, we'll have 2 atoms. Change that coefficient, count it again, and now you have it all balanced. Well, that's all for today, folks. I hope this video was enlightening for you, and that you now understand the law of conservation of mass and how to balance a chemical equation.